Hello, Math 2 students. Today's the day that we find out about the third type of quadratic equation that we have to look at. We first learned about standard form, f of x equals ax squared plus bx plus c. Then we learned about vertex form, f of x equals a times the quantity x minus h squared plus k. And today it's intercept form, f of x equals a times the quantity x minus p times the quantity x minus q. In each of the different forms, you can tell different things at a glance without doing any calculations. In standard form, you can see the y-intercept at a glance. In vertex form, you can see the vertex at a glance. And in intercept form, you can see the x-intercepts at a glance. One thing that all three forms have in common is they all have an a value that tells you whether the parabola will open up or down and whether the parabola will have a vertical stretch or shrink. The purpose of this part of the video is to help you out with problems that look like this and this and this. So to start with, it says, example, add the graph of the function. And it gives us a function y equals negative 1/2 times the quantity x minus 5 times the quantity x plus 7. Since these are binomial factors, this is called intercept form. And we are going to add this graph, but first we have to make the graph. So we're going to go to Desmos and we're going to make the graph of this function. And once we have the graph of that function, we're going to export it and add the file to this Google form. So I open a new tab and I type in Desmos, desmos.com. I choose graphing calculator. And then I have to type in my function, which was y equals negative 1/2 and then my two binomial factors are x minus 5 and x plus 7. And so there is the graph of my function. I'm just going to double check really quick to make sure that I've typed it in correctly, because when we did an assignment like this previously, a lot of students didn't type in their functions correctly and then they had the wrong graph. So the graphing calculator didn't really help them because it didn't give them the right answers. So I have, I want a lowercase y. Y equals negative 1/2 times x minus 5 times x plus 7. Here I have y equals negative 1/2 times x minus 5 times x plus 7. So it looks like I have it typed in correctly. So I'm going to look at this thing and it's really big. So I'm going to have a crazy scale probably on my graph to fit it all in. So I am just going to have the x and y axis count by 5s. And I export it. And I'm probably going to go with a large square. Yeah, I like that a lot better. And I'm going to make sure the lines are thick so I can see them. And then I go download. And there it is, downloading. So now, in order to find it, I'm going to go to my downloads right here. And I'm going to say show in folder, because that allows you to drag and drop more easily. It's called Desmos graph number 43. And so here's my downloads folder right here. And you can see there's Desmos graph number 43. So I'm eventually going to drag and drop this right into my Google form. So I'm going to move this out of the way for now. I'm going to go back to my Google form. I'm going to hit add file right here. And then it'll let me drag and drop it. So I'm going over to my download folder. I'm getting Desmos graph number 43, drag and drop it in. Then I pick upload. And there it is right there. So when I'm correcting your papers, I can open everybody's graph in one folder and look at all of them at once. So you can't see it here, but I definitely can see it when I'm correcting. All right, so we got the graph. Now we need to move on. The next question says, example, what are the x-intercepts of the parabola? Check all that apply. And there's 4 choices, and apparently I can check more than one. So I'm going to go back to my Desmos tab, and I'm going to look at the graph, and they want to know what the x-intercepts are. So the x-axis is right here, going left and right, and my red parabola crosses right at this point. And so it automatically will highlight the x-intercepts for you. My x-intercepts are -7, 0 and 5, 0. So on the Google form, the answer is just going to be -7 and +5. So that's that answer. Now I'm ready to go on to the next one. What is the vertex of the parabola? So I go back to my Desmos tab. Now the vertex is going to be at the maximum point on the parabola. And again, if I click right on the vertex, it'll automatically set me up with what the vertex is. My vertex is at -1, 18. So when I go back to the Google form, I just type in the point -1, 18. And this is really important. I don't want any spaces. So I have bracket, -1, 18, bracket, and that should be my answer. I'm going to double check one more time. -1, 18, -1, 18. I've got it right. And now I'm ready to submit my form. So what we want to focus on right now is this function right here, which is in factored form. And we want to answer these two questions. What are the x-intercepts and what is the vertex? Well, the x-intercepts are the locations where you go left or right, but you don't go up or down on the graph. So if the x-intercept happened to be here, to get there from the origin, we would go 3 to the right, but we wouldn't go up from there or down from there. So one thing that we know about every single x-intercept is every x-intercept doesn't have an up or a down. So every single x-intercept has a y value that's 0. So we know that our x-intercept is going to look like this. It's going to be something, 0. And it turns out on this problem that we're going to have two x-intercepts. And so we're going to have two ordered pairs that is something, 0. So how far over do you have to go to get to the x-intercept? And then we know it's 0 up or 0 down because it wouldn't be on the x-axis if you went up or down. So we want to know what are the x values when the y value is 0. What are the x values when you don't go up or down in the y direction? So what we really want to do is solve this equation. And to solve that equation, we use the zero product property. Here in front of our parentheses, we don't have a variable. Here we look at the binomial factor, and there's no number in front of the x. There's no coefficient, so we can just use the opposite. So here, x would equal 5. And the reason that's the answer is because 1/2 times 5 minus 5, which is 0, times 5 plus 7, which is 12, would be 1/2 times 0 times 12, which is 0. So by making this set of parentheses 0, we're making this side of the equation equal 0. Here we also have an x with no coefficient, so we're going to use the opposite. So that would be x equals -7, and that's a solution to this equation because that would be -1/2 times -12 times 0, and -1/2 times -12 times 0 is 0. So these are the two x values when the y value is 0. So our x-intercepts, 5, 0, and our x-intercept is -7, 0. So if we put those on the graph, 5, 0 would be right here, over 5, but not up or down because it's the x-intercept. And then -7, 0 would be here, 7 to the left, but not up or not down because then it wouldn't be on the x-axis. So those are the two x-intercepts. So our parabola is going to open down, have a vertical shrink of 1/2, and it's going to pass through these two intercepts. So it's going to look something like this. So the vertex is probably going to be up here somewhere, and now we're going to figure out how do we find the vertex. Well, the one thing we know about a parabola is it's symmetrical. So the vertex is going to be exactly in the middle between the two x-intercepts. So I have one x-intercept here and one x-intercept here. if I find the exact midpoint of those two, I will know where the vertex is. So I go in one from the left, in one from the right, in one from the left, in one from the right, in one from the left, in one from the right, in one from the left, in one from the right, in one from the left, in one from the right, in one from the left, in from the right. This is it right there. This is going to be our axis of symmetry. So our vertex is going to be somewhere on the axis of symmetry. So our vertex is -1, comma, something. It's going to be somewhere up here or somewhere down here. I think probably up here because I know that the parabola is going to open down. Now to find the y-coordinate of the vertex, I have to go back to my original problem, and I want to find the y when the x is equal to -1. So now that's going to look like this. I want to find the y. I want to find the y when x is equal to -1. So that'll be y equals -1/2 times -6 times +6. So that'll be y equals -1/2 times -36. And -1/2 times -36 is +18. So our vertex is at -1, comma, +18. So it would actually be way up here somewhere off of my graph. Before we're done, I want to show you one more way that we can find the x-coordinate of the vertex. Because it's exactly in the middle, in between 5 and -7, there's a way, a formula that you can use that helps you find the x-coordinate of the vertex if you're not looking at the graph. You can find this exact middle point by making a calculation. And the calculation goes like this. X equals P plus Q divided by 2. So if we take this coordinate and that coordinate and add them up and divide by 2, the answer is going to come out to -1. And this is a method that we could use if we didn't have a graph. So that would look like X equals P plus Q divided by 2. And so right now, our x-intercept is 5, and our x-intercept is -7. And so 5 and -7 is -2/2, and -2 divided by 2 is -1. So another way of finding where the axis of symmetry would be, where the x-coordinate of the vertex is by adding your two x-intercepts and dividing by 2.